Dear students, this dear students, this video is an introduction to a simulation of a microprocessor based system, an 8086 microprocessor based system using a software called as Proetus. So Proetus is a software where you can simulate a, an 8086 based system. As you all know that 8086 is a microprocessor which does a processing work. What it's going to process? It's going to process a data which is coming from the peripheral, or it is going to give out the data to the peripheral. So there are two ways a microprocessor based system can be developed. One is using physical hardware. Physically you can use a breadboard and you can use the connections to do that thing, and or else you can design a PCB. That sort of system can be developed. Another way is to use a simulation software such as Proetus. So the lab 7 is to interface a 7-segment LED to the 8086 microprocessor. So what are you going to do in this? You're going to use an 8086 microprocessor, and then you use a peripheral controller, programmable peripheral controller, which is called as which is called by a number 8255. This 8255 details can be learned when we teach you about interfacing, right? So there are different peripheral controllers, or there are different microcontrollers, programmable peripheral controllers used along with 8086 when you are using any peripherals connected to the 8086 microprocessor. Now, in this system, we are going to use 8086 microprocessor. We are going to use a 74HC373. This you already know that we are actually separating the data bus, right? So that database is, we are using this, and then there is this 8255 programmable peripheral interface. Then you have a port A. This 8255 has got three ports: port A, port B, port C, from which the data is going out to the peripheral. Now, peripheral, what we are going to use is a 7-segment LED. So we will develop this system. We will see how it works when we write a program for this 8086 microprocessor to display number, hexadecimal number 0 to F in this 7-segment LED. So without wasting much time, we will just now go to Proetus and we'll see how can we start our uh, 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 simulation of 8086 based microprocessor system to interface a 7-segment LED to the 8086 microprocessor. So then let us just go to our desktop. See how we are going to start is, let us go to desktop, double click on the Proetus 8 professional software. Those who are on campus, you can directly double click. Those who are on online, you just have to connect through WebEx and you double click on this. Moment you double click on this, you will get a screen like this, right? So whichever uh, version you are having in your system, that version will be displayed here. You can see here. Now, if you already have a project, you can open a project. But initially, you have to start a new project. Just click on the new project. So you can see the new project menu will be opened. So here, you have to give a project name, and that project name will be saved in this folder. You can choose your own folder if you want. Otherwise, you can save it in a folder documents. Now, I will just give a file name as my LED. I'll just give a meaningful name so that I can remember. Okay. And don't change anything. It's a new project here. It's a folder. Then click on next. Now keep it as a default. See, this is actually, it's going to tell you on which size uh, of a paper you're going to draw your entire schematic. Here you're going to draw the schematic of entire 8086 microprocessor system. So it's asking you whether you want to use A4 size, whether you want to use A0 size. Just select one default, doesn't matter. So here, see, just click on create a schematic from the selected template. Right? Just click on create a schematic from the selected template. Don't click on do not create a schematic because you have to create a schematic here. So don't click on do not create a schematic. Just keep it like this only. Okay. Then press next. Here, very important thing. This menu is very important thing. Here, you have to create a firmware. Firmware means you are going to do both hardware design and also corresponding program. That is assembly program, right? That's why create a firmware project. Now, family, you select it as 8086 microprocessor, right? And here you should select MASM32. It's very important. Okay, MASM32. So if it is not installed, you just have to install it by clicking on this. I'm sure most of the system it's already installed. You need not do anything. Don't unclick anything here. Just go to next. Now here you can see you're going to create a schematic and a firmware. Now just click on finish. You can see two window will be opened. So one is for the source code, okay, another one is for the schematic. One is for the source code, another one is for the schematic. Now here it is very important, right? So how do you control these schematic, right? See, just observe my mouse here. Just observe my mouse pointer. See, this is in the center. Your schematic can normally it should come within this size. This is called as default size of your schematic. Now this is your 8086 microprocessor. I will just keep it in one side. Just keep it here. Just keep it in one side here, right? Now, see, if you want to zoom this, right, you have to use the mouse wheel and you can rotate mouse wheel forward and reverse so that it will be zoomed. Can you see this? It will be zoomed. See, when you zoom, it is going out of the screen. Can you see this? It is going out of the screen. To bring it into the screen, what you do? See the left. Uh, there is a small window here, right? See here. Now, what you have to do here is you can see this green rectangle. Now you click here, move this green rectangle here. See, you can just see the zoomed version of your schematic. Now you click on this window only, then come to this main window. What happens if you don't see? If you don't click once again here and come here, it won't let you to come here. See, it will rotate within this. If you want to come to this main schematic window, you click here once again and then come here. See, then it will come here. Be careful about it. Okay. And you can see by default, whenever you select 8086 microprocessor, you can see reset pin is connected to the ground. By default, it will come. And you can see the min max, it is working in the minimum mode. Okay. And you can also see ready pin also connected to the high. This is actually the power. This is power connection. It's connected to high. So you need not do this connection. Okay. Now your 8086 microprocessor is already placed. Now, if you see your manual, okay, you require, you can, the circuit diagram which you have to draw is already here. It is actually shown here, right? You are supposed to take a printout of this and you can keep it with you always. It is shown here. Can you see? It is shown here. This is the circuit diagram. And see, in circuit diagram, you see what are the components required. What are the components required? So you require one 8086. I will rotate this for your reference. I will the rotated view. This is what you're supposed to draw there. This part is already come. This part is already come there. Now you have to do remaining connections. Now you have to add these components. All these components you're supposed to add. Right? How do you add this component? Come to the notice, click on P, click on P, right? Click on P. Moment you click on P, okay, your device menu will be opened, right? Now what is required? You see you see your circuit diagram. What is required here is 7474 HC373. Just put it here. Come to these keywords. Come to these keywords. Just put it as 74HC. Okay, 74HC 373. Just put it like this. See. Click on this. Click on this. Click on this. IC is ready. Okay, you can see it is added. It is added. Can you see it is added here? Okay, similarly, what you do now? You click on this. You click on this. Come to the schematic window. Come to the schematic window. You can see one pointer there. Click once. Click once. It is moving. Can you see? It is moving. You can place it wherever you want to place it. Then click once again. Okay. Now, another instance can be created by once again clicking it, but it is not required. So what you do, you press escape, right? You press escape now. Okay. Now, because if you click once again, that will be placed once again here. See, if you click once again, it will be placed once again, right? That's why don't click again. Press escape, it will go, right? Okay. Another component required is A255A. Add A255A. See, you can just uh, shrink it to whatever size you require, and you can come here and adjust it to a very nominal resolution you want. See, you can just bring it here like this. See, okay, okay. Now one more component you have to add. You just press on click on P, and then what you do is just put here A255A. See here, click on this. You can see 8255 is added here. Click here, come this side, come this side. Here you can just place this. You can just place this like here. Press escape. Another instance is not required. Now one more component you have to add is 7-segment LED. So 7-segment LED, you can see in the manual it is 7-seg MPX1CA. So how do you search it? Go to P. Now here you give 7-segment MPX. Okay, if you just put 7-segment, it will come. Everything will come here. See. Now here you search for that 7-segment MPX1CA cathode, common cathode. Okay, X1CA. See, this one you're supposed to press OK. It has come here. Now click on this and now place it here. Place it here. Place it here like this. We're understanding this. Now, one more thing, what is required is logic state. The logic state, that is, which gives you 0 and 1 logic state, that also you need to instantiate, you need to bring it. So you just put it as logic state here in the keywords. Logic states. Okay, logic state. So immediately you can see logic state, logic state has come here. Press OK. Now wherever it is required, you place it. You require one here, one here, and you require one here. Now your all the components are ready. All the components are now ready. Now you have to do the connections. To do the connections, you need to have the circuit diagram, or you can say logic diagram with you, right? So you can zoom it to whichever level you want so that you can do the connections. Now first let us draw a bus, data bus connection. Okay, so to have a draw a data bus connection, you just have to go to terminal mode. Click on the terminal mode. Can you see there is one terminal mode here? Click on the terminal mode. Click on bus. Now place that here. It will give you the bus terminal. Okay. Now you place it here. Place it here. After that, you can see this. You have to do the connection. To do the connection, you can see this pointer is pointing the tail of that, right? You just click on that and just drag it down. And here you once you reach here, you double click here. Double click. You have to do double click. Proper double click you have to do. See, otherwise all this nonsense will come. See, if you don't double click properly, if at all you get any connection like this, you do undo changes, it will go. See, now it is properly placed. Can you see this? Now you just have to click on the this arrow mark. This is called terminal. Double click on this and you type the same thing whatever is written here. That is AD 0 2 dots 15. This is very important to do. This is very important to do. See, that will come here. Can you see? That will come here, right? So now we have used connection for the data bus, because same can be labeled, same data bus can be labeled wherever you want to connect, put a data bus. Okay. Now, as per the circuit, this also has to be connected to data bus. So what you do, just once again click on the bus, place one bus terminal, drag it like this, drag it till here. Double click. Proper double click is required. See, otherwise this thing will come. Proper double click is required. See. Okay, you can press escape, double click and escape. Okay. See, if you do now undo, that will go. See, that will go. Hope you are understanding this. Suppose if you want to remove this. Okay, if you want to remove this, just select this. See, just select this and press delete. See, while selecting it, you have to select only that. See, now you delete it. It will go. If you want to delete it, if you have not done it properly. So if you want to put it once again, click on the bus, place, keep your cursor here. Now drag it down like this. Try to put a space here because you have to press escape. See, after clicking only you have to put escape. See, double click. See, once you see, you have to do it like this. See, it is ready now. Now you can see still some more lines are coming. If the lines are coming, you press escape, that lines will not come. See, that lines will not. Double click and then escape. Then that it will be free from that. Okay. Now, how do you do the connections? See here. Just click on this point. Just click on this point, pin. Just click once, drag it, and click here once again. Okay. Once again, click here and click once again here. Click here, click once again here. Click here and click once again here. Click here and click once again here. Can you see how I am going to connect it? See, like this you have to do the connections. Hope you're understanding this. Okay. Like that you do all the connections, and now you have to label this. You can see in this you have the label. See, you have the label here. You have AD0, AD1, AD2, AD3, everything is labeled here. Can you see label? Here also you have the label. So how do you connect that label? That label can be done like this. See here, you click on the label. Can you see LBL is there, wire label mode? Click here and place it somewhere where you have enough space to see those address data lines, address data lines. Okay. Now click here. See, this string menu will be opened. Now here you write AD0. This is an AD0 line. Now click on this. Click on this here. This is AD1. Click on this. This is AD2. Like that, you just try to write everything here. AD3, and this is AD4, and this is AD5. This is AD6. Like, try to put all the things here. This is AD7. Right? So hope you are understanding this. Now you try to complete all the connections as per the connections. Circuit connection is given to you. Do all the connections. These connections are very easy to do. So for example, I will take one connection here. Suppose if I have to connect this, suppose if I have to do this connection, see, this read signal is connected to the read pin of the 8255. Similarly, you can see the write signal is also connected to write. So how you do that? You can zoom it little to whatever range you want. Now, see, this is coming in between, so just place it wherever you find it better. So even this entire set can be connected and moved here somewhere. Okay. Select only this part. Okay, and you can move it like this if you want to have a proper space. So now read connection. See, click here. Just click here and drag. You can just see this. You can connect this. Click here so that it can come straight here like this. See. Similarly, write signal can be connected to the right signal. You click once here, then you can take a turn it. Okay, this is what the connection you have to do. So hope all of you understood that how to do the connections. So you can zoom it as per your comfortable level. See, as per comfortable level, and you can just do the connection. Try to do all the connections yourself, and see, you can see this connection also can be done very carefully. You just have to be careful about this. See, when you connect it like this. Okay, so complete entire connections. Then what you do is, then you just have to double click on this. One small change you have to do here is just go to internal memory size. You make it 0x10000 and just press OK. That's all. Okay, after doing all the connections. After that, okay, what you do is you have to type in this program. Okay, so whatever program is given to you, you can type in this source code, that is source code window, right? The program is already given to you here. Don't try to copy and paste these programs. You are supposed to type there. See, this program, whatever is given here, you're supposed to type it. So you can see that some part of the code is already there. For example, code segment, public code, all these things are required. But if it is not a part of your code, you can just remove it and you can start typing the program. See, you can start typing the program. I'll just you have a rotated view. Okay. What happened? Yeah, these programs you're supposed to type. See, data segment, this entire program, exactly what is there given to you will be typed here. Okay, explanation of the program will be given whenever this memory interfacing is taken in the regular session, in the class session. Entire program you're supposed to type here, right? Okay. Once you are done with the connections, you can see something like this. This is what you're supposed to do as a schematic, and your program is typed here. Entire program is typed here. You're supposed to type it. Once you're done with the program, what you have to do is you have to go to build. First, you have to compile the program. You just have to build project. So if the program is properly entered, if there is no error, it will show you compiled successfully. Otherwise, it will show the error. Then you have to go back to the program and check what is the error. Right? Once it is done successfully, once the build is done, go to your schematic. Right? So go to your schematic and then just go to debug and click on run simulation. Now, can you see it is actually displaying the number 0 to F. See, once it displayed 0 to F, it will go back to 0. Continuously, it will do that. So, this is the way you can simulate interfacing 7-segment LED to the 8086 microprocessor. And to interface 7-segment LED to 8086 microprocessor, you need to have a 8255 programmable peripheral interface microcontroller. This is programmable chip, and it has got 3 ports: port A, port B, port C. You can connect one more LED to port B and you can send some data to this. You can have a multiple display for this. Now this experiment is to make you aware of the interfacing experiments to 8086 microprocessor. And you can do it using hardware also. If you have a 8086 microprocessor, if you have this 75HC373, and if you have all these components, you can do it using breadboard and you can do the same experiment. But it's not required now. Now you just have to learn using this, right? So hope all of you understood this. So do it carefully. You need to have a lot of concentration when you do this, okay? And wish you all the best.